Okay, so this podcast is going to focus on the actual process of forming ionic bonds. As we've talked about before, ionic bonds are formed when electrons are transferred. And so we're going to fill out page 6 that goes over how they're transferred, how they're moving. And it's really important that they are moving from one atom to another. So we're going to use Lewis dot structures in order to help us illustrate this. And if you don't remember, Lewis dot structures have valence electrons drawn around the element symbol as dots. That's our dot structure. And dots get drawn on the sides of kind of an invisible box around the symbol. So if this was my symbol, we've got kind of an invisible box around it where those dots are going to be going. They're always going to be on the sides, not the corners of those boxes. But a box is invisible, we don't draw it. And one dot goes on each side before any side gets 2. So we do have to determine how many valence electrons an element has, but that just comes from its column in the periodic table. Na, sodium, is in the first column, so it gets 1 dot, and it doesn't really matter where it goes as long as it's on one of those sides. Magnesium's in the second column, it's going to get 2 dots, and it doesn't matter which sides they're on as long as they are on separate sides, not together. Boron gets 3 dots, all 3 on separate sides. Carbon gets 4, along with everything else in its column. Nitrogen gets 5. Notice here, I have one side that's doubled up, and then 3 sides that each just have 1 electron. It's really important that we have these drawn in the right places. Oxygen gets 6, 2 doubled up sides and 2 sides that just have 1. Fluorine gets 7, and neon gets 8. So just reminding you how we draw these out. Also reminding you of the octet rule. These are the number of valence electrons all of my elements start with, but atoms need 8 valence electrons to be full and stable. So neon is full and stable, and it's not going to react, and we're not going to see it very much this unit. But that every other atom is going to be transferring electrons in these ionic bonds in order to get 8 and be full. So these are some rules or kind of directions for how we're going to do this, but they're not written very well. So we're going to edit these real quick. So first rule, we got to cross out a few things. The first thing we're going to be doing is drawing each individual element separately. Whichever elements it tells us to bond together, we're going to draw each of those separately with the valence electron dots that they need. Then just cross out that entire second step. We're going to actually show this transfer, this movement of electrons. So we're going to use arrows with those original atoms to show the electrons moving from our cations that want to lose electrons onto the atoms that are going to gain electrons until all of our atoms are either completely full with 8 valence electrons or empty. So we need to find those kind of empty holes and fill them in. Then that's kind of the process of setting up this plan and seeing where these electrons are going to go. Then our last step is actually going to be to redraw those same elements, those same atoms, with their new electrons, either full or empty, and put them in some square brackets with the charge on it. It's going to look kind of like this right over here, in order to show that these are separate ions, but they were formed together in this ionic compound. So that all seems like a lot. Make sure you've edited that so that you can see those steps, and now we're going to actually go through this process with a couple of examples. Okay, so first few examples, and you'll notice I have kind of a condensed, summarized version of those same steps that we talked through without all the edits right up top. So first we're going to draw each element separately with their own valence electrons. So this tells me I'm doing a Lewis dot diagram for a compound between sodium, Na, and chlorine. Sodium's in the first column, it gets 1 dot. Chlorine, it's 7. Now, I'm strategically positioning these dots, and you'll kind of see why. This isn't the normal way I might draw chlorine, but these are each of our elements separately. Now it says to use arrows to move electrons until all atoms are full or empty. So I'm not actually going to redraw any dots. I'm going to draw arrows, and I'm going to use those arrows to move electrons so that all of my atoms are either full or empty. Now, I could probably draw arrows to move all of these electrons over here, but we don't want to do all of that. It's a lot simpler to move that one electron from sodium over into that one space that chlorine had that it didn't have an extra electron in. And that's exactly what the atoms do. Remember, they're going to take the shortest path to getting that octet rule satisfied, either by gaining or losing electrons. So we're going to kind of follow their example and be lazy and do as few changes as possible, move as few electrons as possible. So Na loses one, Cl gains one. That's that second step, just drawing an arrow. Now we're going to redraw our atoms, Na and Cl, with their new electrons, meaning Cl now is going to have 8 valence electrons around it, and Na is going to have none. And then we need to put each of them in square brackets and give them their charge. Now, I could go back to the periodic table and try and figure out what the charges are, but we just gave these elements charges by whether they gained or lost electrons. So Na lost 1, so that becomes a positive 1 charge. Chlorine gained 1, so that becomes a negative 1 charge. Now, don't think of this stuff over here as the answer. All of this is the answer. This is the process of forming an ionic bond. So on our quiz that we're going to have very soon, you need to be able to show all 3 of these steps in your formation of the ionic bond. So, second example is calcium and sulfur. So calcium gets 2 valence electrons, 2 dots. Sulfur gets 6. I'll model putting 1 dot on each side before doubling up. I'm trying to make sure that these dots are more than just a single little pinprick. I need to be able to see these and tell the difference between this and a stray mark, so it's better if you can make these clearer and more dot-like. So those are our original elements. Step 1 is done. Now we're going to draw arrows, and this time it really is going to be multiple arrows because I have multiple electrons that are going to need to move. But similarly, sulfur had a space open there and here. That's where my 2 electrons from calcium are going to come over and fill in those spaces. And now I'm going to redraw each of their symbols, put them in square brackets. Sulfur needs all 8 of its electrons around it, and then give them their charges. Calcium lost 2 electrons, so it became a positive 2 charge. Sulfur gained 2, so it becomes negative 2. Not too bad, right? Well, it's not quite always this easy. These next 2 are going to make us think a little bit more about this process, but it's really not going to be that bad. So I'm actually going to make this a little bit bigger. Okay, a little bit better. So here I have potassium and oxygen, and so our potassium gets 1 dot, our oxygen gets 6 dots, just like that sulfur did. Oop, that's 6. And now, as I start trying to draw my arrows and move my electrons around, this 1 potassium is definitely going to be the one losing. That 1 dot can come over and fill in this one kind of space that oxygen has there. But oxygen has another space sitting over here. That isn't filled in. So this is actually not quite done yet. We have to have all of our atoms completely full or empty. And while potassium is going to be empty, this oxygen isn't full. So what we're going to have to do here is actually add another potassium. And its potassium, with its 1 little dot here, can now come over and fill in this space. So we're going to go through the process of figuring out how to write compound formulas and figuring out how many of each of these elements we need next class period. But for now, we just need to make sure that we keep adding elements and symbols that we need, whatever we're missing. I was missing something that could give me another electron, so I drew another K. That's a giver, giving up electrons. So now all of my atoms are going to be full or empty. Time to redraw our atoms with their new electrons. And instead of drawing 2 separate Ks, I'm just going to put K, put a coefficient 2 in front of it. That way, so that I don't have to draw them out separately again. Once I've kind of figured out how many I need, I can simplify this down. The oxygen is still, it's going to look a lot like that sulfur. It's going to have its 8 valence electrons, square brackets, -2 charge. And we just needed one of them, so there's no coefficient, nothing crazy going on there. Okay? So we need to make sure in that step 2 that we're thinking and making sure that we have the right valence electrons for each of our elements. And even if we don't completely fill and empty, we add what we need to get there. So in this next one, it says magnesium and fluorine. So magnesium's in the second column. It gets 2 dots, 2 valence electrons. Fluorine is a halogen, which gets 7. If I wanted to start moving electrons over, there we go. Fluorine has this space filled now, or it will once that moves over, but I've still got this electron sitting on magnesium that has no place to go. So I need another fluorine. I need to give that other electron a place to go. And it doesn't really matter where they're at. I could draw this other fluorine over here if I really wanted to, as long as all of them get spaces to go to. So this is kind of the problem solving, the planning. Okay, these are how many electrons each of my atoms have. These are the spaces. This is where they're going to go. Okay, all my electrons have a place to go. So we're done. And magnesium is going to be the empty one. Fluorine is going to be full. And in order for this compound to be correct, I had to have 2 fluorines. So, just kind of problem solving, thinking as we do this. Remember, all of this stuff, this whole thing in here, is our answer. It's not just this stuff over here. So, this next 2 examples, I'm actually going to have you do the next example for your stamp. I'm going to do this next one real quick, just to show you how this can get a little bit complicated. But it's not that bad. You just kind of keep doing what you're doing. So, barium has 2 valence electrons. Nitrogen has, actually I'm going to put the double dots over here so that all of those spaces are facing barium. Just being strategic about where these dots are. Now I'm going to start moving electrons over, and this one can fill in this hole, this space. This one can fill in here, but I still have another space here that isn't filled. So I'm going to need another barium. So I'm going to draw another barium here with its 2 valence electrons. And now I can fill in that one extra hole that nitrogen had, but now I have an extra electron on this barium. So I need another nitrogen to help give that enough space to get rid of it. This nitrogen is going to look just like the last one. And now my barium's electron has a place to go, filling in this space on this nitrogen. But now this nitrogen has more spaces to fill in, and I have to add another barium in order to give it electrons. Just keep adding what we need until all of my atoms are full or empty. And finally, I got there. So step 3 is to redraw the atoms with their new electrons. Barium is empty. It lost 2 electrons for each of them, but we needed 3 of them in order for it to work out. And then our nitrogen is full with 8 electrons around it, which would of course cause it to have a -3 charge. And don't forget that we needed 2 of those in order to make this compound work. So these can get a little bit, but just keep adding atoms until you have what you need. All of our atoms are full or empty. So make sure you do the second to last example so that you can get your stamp for all the hard work you've been doing. But that's the end of our podcast. We'll go over more ionic compound naming and writing formulas next class.